Hello everyone, welcome to my channel. You're watching Antik with Sandeep Das, and in this session today we're going to learn about containerization of GoLang, and more precisely we'll cover understanding Docker and containerization, the basic concepts. Then we'll cover how to write Docker file and automate Docker images, and then we'll cover the interaction with the Docker APIs, and finally I'll just cover the container orchestration basics. Let's get started. Oh, before that, if you didn't subscribe my channel yet, please do subscribe my channel and don't forget to click on the bell icon. Now that you've done it, let's get started. Now, let us understand what exactly is Docker and containerization. Okay, so what is Docker? Now, Docker is a platform used for developing, shipping, and running applications. It uses containerization technology to make it easier to create, deploy, and run application using the containers. Now you'll ask me, Sandeep, what is the containerization? Now, containerization is a technology that encapsulates or contain an application and all of its dependencies into the container that can run any server or any machine. Okay, and this helps to ensure that the application runs in any environment in a consistent manner. Okay, then what are the key concepts you should be aware of? The first one, that is the containers. Now, containers are lightweight standalone package that contains everything needed to run a piece of software, which includes the code, runtime, means the OS, system tools, binaries, and all the settings that required to run the application. Okay. Then the images. Now, images are kind of a blueprint for the container. They are used to create containers and specify their contents and configuration. So you store all the OS data and every data into these images, and container are actually running state of all these images. Okay. Now then, what is the Docker file? A Docker file is a text document that contains all the commands a user could call to assemble or build the image. Okay, and finally, there's a Docker Hub. Now, Docker Hub is a registry of Docker images where you can easily find and share container images there. Okay, now let me teach you how to write a Docker file. Okay, here in this, you see all these commands. Before going into all this deep, okay, let's understand what exactly is Dockerfile in a simpler way. So what is Dockerfile? Dockerfile is a text document containing a set of instructions to build a Docker image, and each command in a Dockerfile serves a specific purpose in the image creation process. And this all are the commands. Okay, I'll go one by one. First one is the from command. Okay, so this command specified the base image to use as a starting point. For example, from Ubuntu 18.04 or 22.04, whatever it is. Okay, then run. Now this run command executes a command in a new layer on top of the current image and commits the result. For example, run apt get update and apt get install Python. So it will install Python, for example, in a Ubuntu 18.04 image. Okay, then CMD. Now CMD provides a default command to run when the container starts. Now it will not immediately execute, it will only execute when you start. The good feature in this CMD, you can override this. Okay, now this label command. Now this commands add metadata to an image. For example, as a key value pair, for example, we have this label, then maintainer is equal to your email address. Then expose. This expose command inform Docker that the container listen on a specific network ports at runtime. For example, port 80 or port 3000, 4000, or 3006, whatever the port that you want to expose. Then env. Now env command set as environment variable. For example, env then space myvar is equal to value. So it will be in your application you can access this myvar variable, environment variable. Okay. Then add copies new file directories or remote file URLs from the source to the file system of the container. Okay, for example, add then local directory, that's the current local directory, and then into the container space container directory. Now the copy command. Copy commands copies new files, directories, or remote file URLs from the source to the file system of the container. For example, copy then local directory space the container directory. Okay, then entry point. Now entry point allow you to configure a container that will run as an executable. Okay, for example, entry point Python, then the Python code that you run. Then the volume. Now volume creates a mount point to an external volume or a container. For example, volume, then my volume. Okay. Now this user command. Now this user command set a username or UID to use when running the image. For example, user, my user. Okay. Then work directory, and this work directory command set the working directory for any run, cmd, entry point, copy or add instruction. For example, work directory, then the particular path there you want to host your or store your application. Okay. Then arg or arguments. This defines a variable that users can pass to build time to the builder with the docker build command. For example, argument version is equal to 1.0. Okay. On build. Now this adds a trigger instruction that is executed at a later time when the image is getting used as the base for another image. Okay. For example, on build run, then the command that you want to run it. Okay. Now this is the basic of the Docker file. Now let me show you practically how the Docker file works. Now in this example, we'll cover the Docker file. Okay, in practical way. Okay. So if you remember, in that day 7, we had this Go REST API. Okay. That day 7 code only I just copied in the day 9, and I made this another folder with the name that is the this one. Okay, that is Go REST API container example. Here what I did, here I have like all the things the same. I just added two things: Docker file and Docker production. I will come to the Docker file production just after a few minutes. For now, just focus on the Docker file. If you see from the base image work directory, I'm setting the work directory. Copy, I'm copying the go mode file and the go sum file. Then I'm running a command that is go more download. Okay, and then copy. So copy from the local all the local files into this app directory, and then I'm running the go command, which is CGO enabled, to make sure there is no statically linked C binaries. Okay, so go can run this particular the final binary generating that can run standalone. For that reason, we are having this CGO enabled, and the target OS is the Linux, and then the build command. So go build a, then install suffix. Again, this is the CGO related command. I will come to the later on, and then the final binary that we are generating, that is the main. Okay, and since we are running the application on port 8000, I'm exposing the port 8000, and finally I'm giving the default command, that is cmd main, and this can be overwritten, by the way. Okay, now to build the image, what command I have to run? I have to run docker build, then t, then say the tag, and we will call the tag as, for example, REST API. Okay, v1, and then dot. Say it's pulling this first image, then is doing this, getting the work directory, then copy to all this command that I have specified, that did, and it finally generated the image. How to see the image? To see the image, you have to run docker images. Okay, so let's see, it generated an image that is REST API version, this image with size 1.05 GB. Now this image is actually a big image. Okay, 1.05 GB is big image if you ask me, and big image means more data transfer and more cost. We should not be using big images. We should be, and this is big image in many, and it's not that optimized also, right? We should be optimize this image using the multi-level Docker build. Okay, so what you're doing here, we are having a Docker file here, specifically from GoLang 1.21. we are using as base, using that as a build image, build stage. Okay, where you are running the build, we are generating, like we are downloading all the modules, we are creating the final build in the slash main. Then we have from build stage as the run test stage. Okay, where we are running go test, or as if you have any say test cases, you run it. Okay, then we are deploy the application binary into a lean image. So we are now generating an image that doesn't have any of the thing, just it will be used for the running the application part. Okay, for that you are using gcr.io distortless base dbn 11 image, and then as the build release stage. Okay, which is we are now generating the final image. Okay, and we are setting the work directory as slash, then copying the from the build stage, this one, the final binary which is in the slash main. Okay, so we're copying slash main into this new image. Okay, this as a sequence from this as build release stage. So this is a new stage, new image. There we are just having this final binary. So this particular final image will not have anything extra. It is very clean. It is only what actually required, that is the main binary. Okay, this main file that is there, and I'm running as a non-root. Okay, and then as an entry point. Okay, we can have the option like normally in the CMD, or we can have the entry point, but when you are doing the binary execution, it's better to refer the entry point. Okay, because it's harder to override and you don't want it to be override. Okay, so entry point main, and it will start the, whenever you start the container, it will run on the image. Now let's generate the image now. So docker build dash t, then for example we'll call it the REST API production prod v1. Okay, and dot, then not just dot, okay, dash f, because the docker file name is different, right? It's docker file production, so docker file dot production, you need the dot also. Okay, see, so dot means current directory, and then the docker file path is actually docker file dot production, and it generate the image. Now surprisingly, if you run docker images, see, the production image size actually 29.4 MB, comparing to the development image that is 1.05. So how much reduced? Like a lot. I think more than 90% of the file size got reduced. So that is the beauty of when you like just run, because so Go, you have the speciality of generating the final binary, which is standalone binary. You can run and you can run your entire application, right? So it's better to just generate whatever required in your development stage. Just develop the final binary and then test it if you want to, and it should be, by the way. And then in the this create a fresh image where you have not much, just enough to run the binary, just kind of base Linux image, so that you have from this gci.io dist.less base Debian 11, and there we're just running the main. That way we just have a very small image, 29.4 MB. Okay, so whenever you are thinking of running Go production level, refer to this production level multi-layer deployment, okay, or multi-stage deployment process, or multi-stage Docker build process, whatever you call it. Okay, this is very interesting. Okay, so till now we have run the build commands using what? Using the Docker build command, right? Can't we trigger this build command from the GoLang itself? Actually, that's pretty easy. How can you do it? If you look at this code, okay, of course we'll be using the OS execution package, and you can see we can execute the Docker commands from the GoLang code itself. How? We have to use, of course, OS exec package. Then first we have to just make sure that exec.command, then the command that you're supposed to run, put that in a comma separated way. Okay, just like normally we run the commands, put just in a comma separated way, and from which directory you want to execute the command, mention that, like cmd dot then dir is equals to that particular path. Okay, if you do that and then run cmd dot run command, that command, this particular command, will run exactly from this particular path and will give you the exact result. Why not we just run it and see it, if that works perfectly or not? So just go run docker image build automation. If you run it, it will see, it will generate the image, okay, with the name my app latest. Okay, and it will, the particular, if you see this particular path, that go REST API container example, it's already here, right? And you're running this particular code outside of the folder. That's why I have to mention the particular folder path. And now if you run docker images, you see this my app latest tag got generated, okay, like 29.45 MB. Okay, so similar way, if you for any reason you don't want to utilize the shell scripting, could be for any reason, maybe you want to do it programmatically, you want to get the some values from the database and then do it, could be any reason. And if you want to do that, it is also very easy using GoLang. You can like execute commands and you can achieve your expected result as well. Okay. Okay. So the example just I recently like demo you to guys. That's via the system command. But what if you want to integrate via the SDK? Okay. So I mean, of course, the Docker SDK available for GoLang, Python, and other programming languages. And since it's available for GoLang, I thought I should explore a bit for you guys. So that is why I'm covering that in today's session. We'll have example for Go, PHP, and HTTP, which is via the curl command you can do that. So for today's session, like for today's context, let's focus on the Go code. Okay. So here we are utilizing or importing the Docker APIs. You can see that here, and then you can see in the main we are getting the context, we are creating the client, then you are calling. So this particular code example is actually to run a container. Okay, so that's why all the codes you can see there is just to run the container. Then in the next example it is to run a container in the background. So for that what you have to do, all the codes are here. Then to list and manage the containers you can run this command. Okay, so specifically just create the client. Okay, and then this is just to close after you're done with the calling the APIs. When the main function is that's for closing part. Then this containers, how it's doing that, CLI dot container list. Okay, so this is the API functions context, then type container is optional, and this will store all the container list in this containers array, and then you can just loop through it. So like, there are many such use cases. You have the full documentation also there. I will suggest you guys to try it out. It's very easy, and you might think of many use cases. For example, not just the command line execution, you want programmatically do something or programmatically list of the containers. For example, you are working company whose entire business is to giving container service, or it could be just your running application. You want to know what is the container stat in the particular server and all the other details. Okay, so for all this kind of advanced use cases, you should be focusing on this APIs or Docker SDK APIs. Okay, this will be very useful. Okay, so now let's learn about the container orchestration, and I want to cover Kubernetes basics as well. Okay, so what is this container orchestration? So container orchestration involves automating the deployment, management, scaling, networking, and availability of containerized application. And it is a crucial environment where the application are running a container across multiple machines, nodes, and systems. Okay. Now, why Kubernetes? Kubernetes is one of the famous and the most demanded container orchestration that is available in the market. Okay, and while working with Kubernetes, I want you guys to focus on some initial concept first. Okay, that's why I have listed all that. I'll just go one by one very quickly. Later, we will of course go to a very deep dive while we'll do the API programming for all that. Okay, so the very first one is the node. Node are the virtual machines or machines where you have the Kubernetes component installed. Kubelet. A kubelet is an agent running on each of the node or each of the machines in a cluster. It ensures that containers are running in a pod. Okay. Then kubeproxy. What is the kubeproxy? Kubeproxy maintains network rule on nodes, allowing the network communication on the pod over network session inside and outside of the cluster. Okay. All the network thing kubeproxy handle. Then the Kubernetes API server. This is the front end for the Kubernetes control plane, exposes the Kubernetes API so the other component can interact with the API server. Then the etcd. Okay, so the etcd is a consistent and highly available key value store used as a Kubernetes backing store for all the cluster data. Okay, then the Kubernetes scheduler. So it watches for newly created pods with no assigned node and select a node to run on. So it basically select which pod run on which node. Okay, then Kubernetes controller manager, which is run the controller process handling the routine task in the cluster. Okay, these are all the, you can see the architecture wise. Okay, then there are components. For example, the pod is the smallest deployable unit that can be created and managed, representing one or more containers. Okay, so one pod can contain multiple containers or can be single container. Okay, then service. A service is an abstract way to expose an application running on a set of pods as a network service. Okay, and the volume. It's a directory, possibly with the data in it and accessible to the containers in a pod. Then the namespace. It's a way to divide cluster resource between multiple users. Okay, then deployment. Deployment manages the creation and updation of the pods, maintaining the desired state. Then the replica sets. It ensures the specified number of pod replicates and running at a given point of time. Then there is stateful set. It manages the deployment and scaling of the set of pods and provides guarantee about the ordering and uniqueness of these pods. Okay. Then the daemon set. It ensures that all nodes run a copy of the pod. This is mainly used for the log connection or the health monitoring purposes. Then the job. It creates more or one or more pods and ensure that a specified number of them successfully terminated. Okay. Then cron job. Cron job manages time-based job once a specified point in time or repeatedly at a specified time. Okay, so cron basically you have a you at the say night 12 a.m. something should run, or maybe 6 a.m. something should run automatically. For those cases, you have the cron job. Then the config map. Now, config map store non-credential data in a key value pairs which can be consumed by the pods. Okay. And the secret. A secret store sensitive information such as password, OAuth token, and SSH keys. Then Kubernetes ingress. It manages the external access to the service in a cluster, typically HTTP or HTTPS. Okay, load balancer kind of stuff. Then the Helm. Helm is a package manager for Kubernetes, allowing you to defining, installing, and upgrading complex Kubernetes applications. So these are the pretty basic components that you should be focusing on, because we will be next doing what? Kubernetes related plugin development and all this complex stuff, right? Um, so these are the things you should be at least get know about them. Okay, that all I asked for. Okay, then I'll show you all the complex part anyway, so don't worry. Now this is all for today. Thank you for staying this long, and see you soon in my next video. Bye bye.